Tonight, we're not racing toward the stars. There's no countdown, no roaring engines. Instead, we're pausing, right where we are. Because before asking how far humans have gone into space, we need to understand something quieter, and much more important. How far have we actually left Earth? As you listen, there's nothing you need to imagine clearly, nothing you need to remember. Just allow the question to drift, slowly, into the background of your thoughts. Standing still on Earth, before any human ever left the ground, before engines burned, before metal touched the sky, humanity was still. For nearly all of our existence, we lived entirely on the surface of a single planet. We looked up long before we could go up. The sky became a storybook. Stars were patterns. Planets were wandering lights. The moon was close, but unreachable. For thousands of years, space was not a destination. It was a backdrop, something distant, constant, unchanging. Even as civilizations rose and fell, the stars stayed exactly where they were. This created an illusion that space was nearby, just above us, waiting. But Earth has always been a powerful anchor. Gravity holds everything close. Air wraps the planet in layers. Pressure presses us gently downward. Every breath, every step, is shaped by Earth's presence. Standing on the ground, we rarely feel how strong this grip truly is. We jump and come back down. We climb and eventually stop. Even mountains, our tallest natural structures, barely rise through the thinnest edge of the atmosphere. From Earth's surface, space looks close, but in reality, we are deeply embedded inside our planet's influence. The first thing to understand when asking how far humans have gone into space is how far we haven't. We haven't escaped Earth easily. We haven't slipped quietly into the cosmos. Every step upward has required force, fuel, and intention. Earth does not let go willingly. For most of human history, we didn't even know where space began. The sky faded from blue to black, but there was no clear line. Birds flew high, clouds drifted higher, but eventually, everything stopped. Above that point, there was only emptiness and silence and mystery. When early scientists tried to define space, they struggled. Was it where air disappeared? Where pressure dropped? Where flight became impossible? Even today, there is no solid boundary. Space does not begin suddenly. It thins, layer by layer, until Earth's atmosphere becomes a faint whisper, and then almost nothing at all. This matters because it reveals something subtle. Even when we say humans have gone to space, we are often talking about leaving one layer while remaining firmly within another, still held, still close, still connected. Standing on Earth, we are already part of space. The planet moves through it, silently, at incredible speed. Earth orbits the Sun at nearly 30 kilometers per second. The solar system itself moves around the galaxy. We are never truly still, but motion is not distance. And this is where the illusion begins. From our perspective, launching a rocket feels like leaving home. From the universe's perspective, it barely registers. Imagine Earth as a glowing island, surrounded by an ocean of space. Most human activity, even spaceflight, happens so close to the shore that the water barely ripples. Before the first human reached space, we built towers, airplanes, and balloons. Each attempt pushed us slightly higher, but even the highest aircraft never came close to leaving Earth's grasp. They skimmed the upper atmosphere, still surrounded by air, still dependent on lift. True departure required something else. It required speed, not upward motion, but sideways motion. This is one of the most misunderstood ideas in space exploration. To stay near Earth, to orbit it, you don't need to go far away. You need to move fast enough to keep missing the ground. As Earth curves away beneath you, orbit is not escape. Orbit is falling without ever landing. And for decades, this is as far as humans would go. But before we even reached that point, humanity had to answer a deeper question. Why leave Earth at all? Curiosity played a role. So did competition. But beneath it all, there was something quieter. A desire to see ourselves from the outside, to understand where we fit in a universe that suddenly felt much larger than our myths had prepared us for. Standing still on Earth, we felt small, but also safe. Earth provides everything we need: air, water, warmth, protection. Leaving it means giving up comfort for uncertainty, and that trade has always been difficult. Even today, with advanced technology, humans spend nearly all their time within a thin shell surrounding Earth. Cities cling to the surface. Air travel stays within a narrow vertical band. Satellites, the furthest objects most humans interact with daily, orbit just a few hundred kilometers overhead. On a planetary scale, that is nothing. If Earth were the size of a basketball, the International Space Station would orbit less than a centimeter above its surface. That's how close we stay. That's how strong Earth's pull remains. So when we ask how far into space humans have actually gone, we must first acknowledge this truth. We are a surface species. We evolved for pressure, for oxygen, for gravity. Every step away from Earth is a step into an environment that does not want us. And yet, we took it anyway. Not far at first, not boldly, but carefully, quietly. Standing still on Earth, we prepared, slowly, for the smallest step outward. And that step would not take us far, but it would change everything. Where does space actually begin? After standing still on Earth, after feeling how tightly gravity holds us, the next question naturally drifts into view. Where does space actually begin? It sounds simple, almost obvious, but the answer is surprisingly unclear. From the ground, the sky looks like a boundary. Blue below, black above, a clear divide. But as with most things involving space, the closer we look, the softer the edges become. There is no sharp line, no invisible wall, no sudden moment where Earth ends and space begins. Instead, the atmosphere fades, slowly, quietly, layer by layer. Closest to the ground, the air is thick, dense, heavy enough to breathe, heavy enough to carry sound, heavy enough to shape weather, clouds, and wind. As we move upward, the air thins, pressure drops, molecules spread farther apart, the sky deepens in color, from bright blue to pale blue to something darker. Aircraft reach a point where wings struggle. Lift becomes inefficient. Above that, only rockets can continue. But even there, the atmosphere does not simply stop. It continues upward, far beyond what we can see, far beyond where planes fly. far beyond where clouds exist. Earth's atmosphere extends hundreds of kilometers into space, so thin that it blends almost seamlessly with the vacuum beyond. This creates a problem. If space does not begin suddenly, how do we decide where it starts? For practical reasons, humans created a definition, not because nature demanded one, but because engineering did. That definition is known as the Kármán line, an imaginary boundary, set at about 100 kilometers above Earth's surface. At this altitude, the atmosphere becomes so thin that traditional aircraft can no longer fly. To stay aloft, a vehicle would need to travel at orbital speed. In other words, beyond this point, flight becomes orbit. The Kármán line is not visible. It is not marked. Crossing it feels like nothing at all, but it became a symbolic threshold. Above it, you are said to be in space. Below it, you are not. This definition works well for record keeping, for awarding astronaut wings, for categorizing missions, but it hides a deeper truth. Even above the Kármán line, Earth still has influence. Gravity remains strong. Air, though extremely thin, still exists. Satellites in low orbit slowly lose altitude, dragged by traces of atmosphere. They must boost themselves or eventually fall back to Earth. So even here, we are not free. We are still brushing against our planet. This is important because when we say humans have gone to space, we are often describing a journey that barely clears Earth's outermost breadth. The earliest human spaceflights did not orbit. They went up and came back down. These were suborbital flights, brief arcs into the sky. They crossed the Kármán line, experienced weightlessness for a few minutes, and then returned. From a technical standpoint, they reached space. From a cosmic standpoint, they never truly left Earth. They remained within Earth's gravitational well, never achieving the speed needed to stay away. It was a glimpse, not a departure, a peek beyond the edge, not a step into the void. And yet, those brief moments mattered because they revealed something unexpected. Space, even just beyond the atmosphere, is not dramatic. There is no sudden darkness, no explosive silence, no feeling of crossing a threshold. The transition is gentle, almost anticlimactic. The sky darkens, stars appear, Earth curves softly below. Everything else feels remarkably calm. This challenges the way we imagine space. We picture it as distant, separate, removed from Earth. But in reality, near-Earth space is an extension of our planet, a fading continuation, not a clean break. Even astronauts aboard the International Space Station are still very close to home. They orbit at roughly 400 kilometers above the surface. That sounds far, but on a planetary scale, it is almost nothing. If Earth were the size of a globe in a classroom, the ISS would orbit about the thickness of a sheet of paper above it. That's how near we remain. That's how little of Earth we have truly left behind. And yet, from that vantage point, the experience feels transformative. Seeing Earth from above changes perception. The planet appears fragile, bounded, finite. A thin layer of atmosphere, barely visible, protects everything we know from space. That layer looks incredibly delicate, a soft blue halo, clinging to a dark sphere. This realization has a name: the overview effect. A cognitive shift reported by astronauts, a sense of unity, A feeling that borders disappear, that Earth is a single system, not a collection of separate places. This psychological distance often feels greater than the physical distance traveled. Astronauts may only be a few hundred kilometers away, but mentally, they feel worlds apart. This is part of why the question, how far have humans gone into space, is more complex than it sounds. Distance is not just measured in kilometers, it is measured in experience, in perspective, in how far the familiar begins to fade. But even here, near the edge of space, Earth still dominates. It fills half the sky. It controls your orbit. It determines your fate. If engines stop, you fall back. Slowly, inevitably. To truly leave Earth requires more than altitude. It requires escape velocity, a speed so high that Earth's gravity can no longer pull you back. And that speed is not reached by going straight up. It is reached by building sideways motion, layer upon layer, until gravity can no longer win. This realization reshaped spaceflight. Early missions were not about going higher. They were about staying away longer. Orbit was the first true step, not because it took us far, but because it allowed us to remain. Still, orbit is not departure. It is a delicate balance, a continuous fall around Earth. And for most of human space history, that balance is where we stayed. So when we ask where space begins, we are really asking something deeper. At what point does Earth let go? At what distance do we stop being visitors and become travelers? The answer is not at 100 kilometers, not at 400 kilometers, not even at the edge of the atmosphere. Earth's influence extends far beyond what we call space. Gravity stretches outward, millions of kilometers, shaping orbits, guiding paths, controlling motion. To leave Earth, truly leave it, is rare, and only a handful of humans would ever do so. But before that moment, before escape, before the moon, humanity would spend years circling, observing, and learning just above the surface, close enough to see home clearly, far enough to realize how small it really is. And in the next part of our journey, we'll take that step, not far, but fast enough, into orbit. First, steps upward. Before humans could orbit Earth, before they could float or look back at the planet from above, they had to solve a much simpler problem: how to go up at all. For most of history, upward travel was limited. Birds flew, clouds drifted, but humans stayed close to the ground. Even the tallest structures ever built barely reached into the lower atmosphere. The sky remained distant, not because it was unreachable, but because we lacked the means to reach it. The first true attempts to go higher did not come from curiosity alone. They came from experimentation, from trial, error, and persistence. Early rocketry began not as a space endeavor, but as a study of motion, how gases expand, how thrust works, how mass can be pushed by releasing energy in the opposite direction. These ideas existed for centuries. Simple rockets, using gunpowder, had been used for fireworks and weapons, but they were unpredictable, short-lived, and limited. It wasn't until the early 20th century that rockets became something else. Not tools of spectacle, but instruments of ascent. Scientists and engineers began asking new questions. What happens if a rocket is made larger? What if fuel is burned gradually, instead of all at once? What if stages are stacked, one lifting the other higher? These questions led to experiments. Some failed spectacularly, others barely worked, but each attempt added knowledge. One of the key realizations was that rockets do not need air. They do not push against the atmosphere. They push against themselves. By throwing mass downward at high speed, they move upward. This made spaceflight possible. In theory, in practice, it took time. The earliest rockets capable of reaching high altitudes were known as sounding rockets. Their purpose was not travel, but measurement. They carried instruments, not people. Temperature sensors, pressure gauges, radiation detectors. They went up and came back down. No orbit, no escape, just a vertical journey. Some reached altitudes that aircraft could never achieve. Above clouds, above weather, into the thinning air. These rockets revealed something important. As altitude increased, conditions changed rapidly. Air pressure dropped, temperature fluctuated, radiation increased. The environment became less forgiving, and yet, the rockets continued, higher each time. Still, these early flights remained brief. They touched near space, then returned. They showed that reaching extreme altitude was possible, but staying there was another challenge entirely. To remain above Earth, a vehicle needed more than height. It needed speed, a lot of it. But before that realization became clear, humanity took its first brief steps beyond the atmosphere. Suborbital flights. These missions followed a simple path: upward acceleration, engine cutoff, a gentle arc, and descent. For a few minutes, everything became quiet. Weightlessness appeared. Objects floated. The horizon curved. Space, briefly, was experienced. Then gravity took over. The vehicle fell back, re-entering the atmosphere, slowing, landing. From the outside, these flights seemed small. They covered no great distance. But from the inside, they changed everything. For the first time, humans experienced space directly, not through telescopes, not through calculations, but through sensation. The sky was no longer a ceiling. It was a region, a place that could be entered, even if only briefly. These early journeys were not comfortable. They were noisy, violent, physically demanding. Acceleration pressed bodies into seats. Re-entry brought heat and stress. Everything was experimental. Nothing was guaranteed. But with each flight, confidence grew. Engineers refined designs. Scientists gathered data. And slowly, the question shifted. Not, can we reach space? But can we stay there? This is where the idea of orbit became central. Orbit is often misunderstood. It does not mean hovering. It does not mean floating in place. It means falling sideways, fast enough that the Earth curves away beneath you. Imagine throwing a stone. Throw it gently. It falls nearby. Throw it harder. It travels farther. Throw it fast enough, and the ground never catches up. That is orbit. To achieve it, a spacecraft must reach enormous speed, roughly 7.8 kilometers per second, nearly 28,000 kilometers per hour. That speed is not intuitive. It is difficult to imagine, but without it, spaceflight remains temporary, up and down. Suborbital flights taught humans what space felt like. Orbit would teach them what it meant to live there. But before orbit, there was hesitation, risk, uncertainty. Early rockets were unreliable. Failures were common, sometimes catastrophic. Every attempt carried danger. And unlike aircraft, there was no easy abort. Once launched, a rocket committed itself. This is why early space programs moved cautiously. Incremental progress, short flights, uncrewed tests. Animals were sent first. Small creatures to measure survivability, heart rate, breathing, stress. Each flight answered one question and raised another. Could life endure acceleration? Could it survive weightlessness? Could it return safely? Gradually, answers emerged. Yes, with preparation. Yes, with protection. Yes, with care. And so, humanity stood at the edge of a new threshold, not just reaching space, but remaining there. The first orbital flights would not take humans far from Earth. They would circle it, again and again, never drifting far. But psychologically, they represented a leap, because orbit meant separation, not total escape, but distance. Time spent away from the surface, time enough to look back and realize something profound. That Earth, seen from above, was not infinite, that it had boundaries, that everything familiar existed on a single world. Still, these early steps upward were humble. They did not promise distant planets. They did not aim for the stars. They were cautious, measured, focused on survival. In hindsight, this restraint was necessary. Space does not reward haste. It demands precision. The first steps upward were not heroic leaps. They were careful movements, learning how to climb before learning how to travel. And soon, those steps would carry a human into orbit, not far from Earth, but far enough to change how humanity saw itself. The first humans to leave Earth. The moment humanity first left Earth was quieter than most people imagine. There were no cheers in space, no dramatic music, no sense of triumph echoing through the void. There was only motion, speed, and silence. After years of experiments, after countless uncrewed tests, the question was no longer if a human could survive space. It was who would go first. And when that moment arrived, it did not carry humanity far. It carried us just enough. The first human to leave Earth was Yuri Gagarin. On the 12th of April 1961, he climbed into a small capsule, barely larger than a car, designed for one purpose only: to keep him alive. The spacecraft was called Vostok 1. It had no windows large enough to enjoy the view, no manual controls for flight, no room to move. Gagarin did not steer. The spacecraft flew itself. This was not because of confidence, but caution. No one knew how a human mind would react to weightlessness, to isolation, to the view of Earth from above. So the mission was kept simple: one orbit, one circle around the planet, then return. As the rocket lifted from the launch pad, Earth released him slowly. Acceleration pressed him into his seat. The sky darkened, air thinned, and then, without warning, weight disappeared. For the first time in history, a human was no longer resting on Earth or falling toward it. He was orbiting. From the ground, this seemed monumental. Humanity had reached space, but from space, something else became clear. Earth was still very close. Gagarin orbited at an altitude of about 327 kilometers. On a cosmic scale, that is almost nothing. He never left Earth's gravitational grip. He never traveled far enough to feel alone in the universe. Earth filled his view, blue, white, alive. The planet curved beneath him, slowly turning, uninterrupted. His entire journey lasted 108 minutes. Just under 2 hours, one orbit, and a little more. Then gravity reclaimed him. The spacecraft descended. Heat built up. The atmosphere thickened. And Gagarin returned to Earth, almost exactly where he had started. This pattern would repeat again and again. More missions followed. More orbits, longer stays, but always close, always within reach. Humans had not escaped Earth. They had learned how to circle it. This distinction matters because orbit, while extraordinary, is not distance. It is proximity. Astronauts in orbit remain deep inside Earth's influence. They move fast, but they never move far. The next astronauts experienced the same thing. They orbited, looked down, and returned. Each mission added confidence. Days in space became weeks. Weeks became months. Humans learned how to live without gravity, how to eat, how to sleep, how to work. But they did all of it just a few hundred kilometers above home. Even at its highest point, human orbit stayed close. The record altitude for a crewed Earth orbit was set during the Gemini 11 mission. Astronauts reached nearly 1,370 kilometers above Earth. This was higher than usual, but still incredibly close. If Earth were a city, they had not left the neighborhood. They had gone to the edge of town. And yet, from that vantage point, the psychological distance felt immense. Seeing Earth from above changes something. The familiar becomes fragile. Borders disappear. The planet looks whole, self-contained, finite. This realization was not part of the original plan. Spaceflight was meant to demonstrate capability. Instead, it revealed vulnerability. Astronauts returned with stories, not about distance, but about perspective. They spoke of Earth as a single place, of atmosphere as a thin veil, of how little separates life from the emptiness beyond. This awareness reshaped how humans talked about space, no longer just a destination, but a mirror, a way to see ourselves more clearly. Still, despite this shift, humanity did not move outward. We circled, we practiced, we stayed close. Even as missions grew longer, they remained within Earth's shadow. The International Space Station, often described as humanity's home in space, orbits at about 400 kilometers above the surface. It completes an orbit every 90 minutes. 16 sunrises and sunsets each day. From there, astronauts can see continents, storms, cities glowing at night. They are never far from Earth. Communication delay is negligible. Help, in theory, is only hours away. This closeness is intentional. Low Earth orbit is accessible, relatively safe, easier to reach. It is where humans feel most comfortable. It is also, as far as we regularly go, despite decades of technology, despite experience, despite ambition, we remain close. The first humans to leave Earth did not truly leave it behind. They brushed against the edge and returned. This does not diminish the achievement, it clarifies it. Human spaceflight has always been cautious, incremental, anchored. Even the boldest missions were designed with return in mind, because Earth, for all its limits, is forgiving. Space is not. Orbit offers a compromise. It allows us to experience space without committing to distance. But eventually, curiosity pressed outward. The question changed. Not can we orbit Earth, but can we leave it? To truly answer how far humans have gone into space, we must follow the moment. When Earth's grip was finally broken, not by altitude, but by speed, that moment would not happen in orbit. It would happen on a trajectory, aimed somewhere else, somewhere farther, somewhere quiet, somewhere waiting. The Moon. Living in low Earth orbit, once humans learned how to orbit Earth, something interesting happened. We stopped going farther, not because we couldn't imagine it, but because orbit felt enough. Low Earth orbit became our comfort zone, a place where space could be experienced without being fully embraced. To understand how far humans have actually gone, we need to understand what orbit really is. Orbit is often described as floating, but floating is misleading. Astronauts are not hovering above Earth. They are falling, constantly. They are falling forward, fast enough that the planet curves away beneath them. This delicate balance creates the illusion of weightlessness. Inside a spacecraft, everything falls together. The astronauts, the walls, the air. There is no up, no down. But outside, Earth is still in control. Gravity, at the altitude of the International Space Station, is only slightly weaker than it is on the surface. The astronauts are not free from Earth's pull. They are caught within it. This is why low Earth orbit is so stable, and why it feels safe. From orbit, Earth is always there, always visible, always close. Astronauts can see oceans, cloud systems, coastlines, and city lights. They witness storms forming and fading. They watch day and night sweep across the planet, again and again. This constant presence of Earth anchors the experience. Even though astronauts are technically in space, they never feel far away. Communication is immediate. A conversation with mission control has almost no delay. Rescue, in theory, is possible. Supplies can be delivered, repairs can be made. Low Earth orbit allows mistakes to be managed. This is one reason humanity stayed there. After the first orbits, space agencies began to ask new questions. How long can humans live in space? What happens to the body when gravity disappears? How does the mind respond to isolation and confinement? Low Earth orbit was ideal for finding answers. Missions grew longer. Days became weeks. Weeks became months. Skylab, Mir, and eventually, the International Space Station. Each station orbited Earth at roughly the same altitude. Each served the same purpose: to learn how humans adapt while staying close enough to return safely. Life in orbit is repetitive. Days are structured. Experiments, maintenance, exercise. Astronauts must work to keep their bodies strong. Without gravity, muscles weaken, bones lose density. The human body, so well adapted to Earth, begins to change. This reality reinforces a subtle truth. Even when we leave Earth, we bring Earth with us. Our biology expects gravity. Our senses expect orientation. Our minds expect horizons. Low Earth orbit removes these. but only partially. Earth still fills the window. The planet's presence offers reassurance. This proximity matters psychologically. Astronauts often describe a sense of peace. While looking down, Earth feels protective, familiar, alive. This is not the experience of deep space. It is the experience of leaving home without truly saying goodbye. And because it felt manageable, humanity lingered. Decade after decade, we refined orbit, we improved spacecraft, we built better stations, we extended mission durations, but we did not move outward. Low Earth orbit became a destination instead of a stepping stone. There were practical reasons: cost, risk, politics. But beneath all of that, there was something quieter. Orbit is forgiving. Beyond orbit, space becomes indifferent. Radiation increases, communication delays appear. Rescue becomes impossible. Low Earth orbit offers protection. Earth's magnetic field shields astronauts from much of the cosmic radiation. The atmosphere, even thin, absorbs dangerous particles. Beyond this region, that protection fades. This invisible shield, known as the magnetosphere, extends tens of thousands of kilometers into space. But it weakens with distance. Low Earth orbit sits well within it. This is another reason we stayed. Safety in space is relative, and orbit offers the most safety available. So for decades, human spaceflight became routine, but not expansive. Astronauts traveled higher than aircraft, but not far from home. If Earth were a campfire, we never stepped beyond its warmth. This creates a strange contradiction. Humans are often described as a spacefaring species, but in truth, we are an orbiting species. We circle our planet again and again, rarely venturing beyond. Even our most ambitious projects have remained close. The ISS, often called our home in space, is still within Earth's immediate neighborhood. It completes an orbit every 90 minutes, 16 times a day. Astronauts pass over the same places. There is comfort in this repetition, but repetition also signals limitation. Low Earth orbit teaches us how to survive. It does not teach us how to travel. And eventually, that realization became unavoidable. Orbit answered many questions, but it left one unanswered. If we can live here, why not go farther? Why stop so close to home? The answer was not technical. It was human. Leaving Earth requires commitment. It requires accepting distance without the promise of immediate return. Low Earth orbit offers the illusion of departure without the cost of separation. It lets us experience space without confronting how vast it truly is. But one mission would break that pattern. One series of journeys would carry humans farther than ever before. Not into orbit, not around Earth, but away from it, across a distance so large that Earth would shrink into something unfamiliar. That journey would not take us deep into the galaxy. It would not reach another planet, but it would carry humans farther than they have ever gone, before or since, to the moon, breaking away from Earth. For all the time humans spent in orbit, circling Earth, watching continents drift beneath them, they were never truly leaving. They were guests, moving quickly, but still held firmly by the planet below. To go farther, something fundamental had to change. Altitude was no longer the challenge. Speed was. Earth's gravity is not a wall. It does not stop abruptly. It fades gradually, stretching far into space. To leave Earth, you don't climb over gravity. You outrun it. This requires a specific threshold, a speed so high that gravity can no longer pull you back. That speed is known as escape velocity. For Earth, escape velocity is about 11.2 kilometers per second, more than 40,000 kilometers per hour. This number is easy to state, but difficult to grasp. It is far faster than orbit. Orbit allows you to fall endlessly around Earth. Escape velocity allows you to stop falling back. Once reached, you are no longer bound to circle the planet. You are free to go elsewhere. But freedom in space comes with a cost. When a spacecraft reaches escape velocity, there is no easy return. Every meter per second of speed requires enormous amounts of fuel. There is no coasting back on a whim. Leaving Earth means committing to distance. This is why early human spaceflight stayed in orbit. Orbit is forgiving. Escape is final. The first time humans truly broke away from Earth was not accidental. It was deliberate, planned, measured, and deeply cautious. The destination was not chosen for ambition. It was chosen for proximity. The Moon. From a cosmic perspective, the Moon is extremely close. On average, about 384,000 kilometers away. Light reaches it in just over a second. Radio signals take a few seconds more. Compared to planets, it is a neighbor. But compared to orbit, it is unimaginably distant. Low Earth orbit is a few hundred kilometers up. The Moon is nearly 1,000 times farther away. To reach it, humans had to leave Earth's gravitational dominance and enter a region where Earth and Moon pulled together in delicate balance. The moment a spacecraft fires its engines to leave Earth orbit, everything changes. Earth no longer fills the window. It begins to shrink. Slowly, quietly. At first, the change is subtle. The planet still looks large, still familiar. But hour by hour, distance accumulates. There is no sensation of acceleration, no feeling of speed, just the awareness that Earth is no longer beneath you. It is behind you. This is the moment when humans truly left Earth. Not when they crossed a line, not when they reached a certain altitude, but when Earth stopped being the center of motion, when the planet became one object among others. This psychological shift is profound. In orbit, Earth feels dominant. In transit to the Moon, Earth becomes a destination instead of a foundation. Astronauts describe this phase of flight as unexpectedly calm. After the intensity of launch, after the noise and vibration, there was quiet. Long stretches of time, with little to do. Systems checks, navigation updates, small course corrections, and through the window, Earth slowly receding. This was the first time humans experienced deep space, not deep in distance, but deep in separation. The protective cocoon of Earth began to thin. Radiation levels increased. Outside the magnetosphere, cosmic rays became more present. Solar particles passed freely. There was no atmospheric shield, no magnetic buffer, only the spacecraft's hull and careful planning. This environment is often misunderstood. Deep space is not dramatic. There are no stars rushing past, no sense of movement. Space remains visually still. The only sign of travel is the changing size of Earth, and later, the growing presence of the Moon. This stillness can be disorienting. Human senses evolved for motion cues. In space, those cues disappear. There is no wind, no horizon, no reference frame. The mind must rely on instruments, numbers, calculations. This dependence reinforces another truth. Beyond Earth, intuition becomes unreliable. Space does not behave the way our instincts expect. This is one reason human exploration beyond Earth orbit has been rare. It demands trust in systems over senses. As the spacecraft travels outward, Earth's gravity weakens, but it never vanishes. Even halfway to the moon, Earth still pulls. The moon pulls too. The spacecraft is constantly influenced by both bodies. This region is not empty. It is dynamic, a place where gravitational fields overlap, and trajectories must be precise. Small errors become large over time. Navigation in deep space is an exercise in patience. Tiny adjustments made early prevent large corrections later. This methodical approach defined the Apollo missions. Nothing was rushed. Every maneuver was planned, with redundancy. Fuel margins were tight. Time was valuable, and return was never guaranteed. For the first time, humans were far enough away that rescue was impossible. No quick return, no supply missions, no immediate assistance. If something failed, the crew had to solve it themselves. This realization shaped everything. Spacecraft were designed for reliability. Procedures were rehearsed endlessly. Checklists covered every scenario, not because engineers lacked confidence, but because distance removes options. As Earth continued to shrink, another change occurred: communication delay. At lunar distance, radio signals take over a second to travel. Conversation becomes staggered. Pauses appear. Replies are no longer immediate. This delay is small, but noticeable. It marks the beginning of true separation. Beyond the moon, delays would grow longer, minutes, hours, eventually years. But for Apollo astronauts, this was the first taste. A subtle reminder that home was no longer just up there. It was far away. As the spacecraft approached the moon, another transformation took place. The moon grew larger. Details sharpened. Craters appeared. Shadows stretched across the surface. The destination became real. But something else happened too. Earth, now distant, became something new. Not a world, but an object, a blue and white sphere, hanging in blackness. Small, delicate, finite. This sight would become iconic, not because of its beauty, but because of its implication. Everything humans had ever known existed on that shrinking disk. All cities, all history, all life, contained on something that now fit inside a window. This realization is difficult to overstate. It changed how astronauts thought about Earth. It changed how humanity thought about itself. But physically, this was the farthest humans had ever gone. Beyond orbit, beyond Earth's immediate reach, into true space. And yet, even this distance was modest. The moon is close. In universal terms, it is barely a step. But for humans, it was the ultimate departure. No crewed mission since has gone farther. This remains the record. The moment when Earth finally let go and humans drifted beyond its immediate embrace. not into the stars, not into deep interplanetary space, but far enough to see home as something separate, something precious, something small. And as we'll soon see, the farthest point humans ever reached did not happen on the moon's surface. It happened quietly, in the space beyond it, the moon, our farthest destination. When humans finally reached the moon, it felt like the ultimate journey. For centuries, the moon had been a symbol, a constant presence in the night sky, a measure of time, a source of stories and wonder. It was close enough to see clearly, yet far enough to remain unreachable. So when humanity set foot there, it felt as though we had crossed a boundary, that we had gone far. But distance, in space, is deceptive. The moon is the farthest place humans have ever traveled, and yet it is still remarkably close. To understand what that means, we need to slow down and examine the journey itself. From Earth, the moon appears nearby. You can see its craters with the naked eye. You can watch it rise, set, and change shape. This familiarity creates an illusion that the moon is just beyond reach. In reality, the space between Earth and the moon is vast. So vast that every other human spaceflight fits inside it. All satellites, all space stations, every orbit ever flown. If you place them between Earth and the moon, there would still be room left over. The journey to the moon takes about 3 days. Not because the spacecraft moves slowly, but because space is large. After leaving Earth orbit, the spacecraft coasts. Engines fire briefly, then stop. Most of the journey happens in silence. No sensation of speed, no feeling of travel, just time passing, and Earth slowly shrinking behind. By the second day, Earth no longer dominates the view. It becomes something you must search for. A bright point, a familiar color, in a sea of black. This is when astronauts truly understood how far they had gone. Not through numbers, but through absence. Earth was no longer always present. The moon, once distant, now grew steadily larger, cratered, gray. Still, unlike Earth, the moon has no atmosphere, no clouds, no weather, no soft edges. Shadows are sharp. Light is harsh. The surface looks ancient because it is. The moon is a record of early solar system history, unchanged for billions of years. When Apollo astronauts entered lunar orbit, they did not feel triumphant. They felt focused. Everything was precise. Fuel margins were tight. Trajectories were exact. There was no room for error. Landing on the moon was not a single maneuver. It was a sequence. Orbit insertion, system checks, descent. Each step required calm. The moon did not forgive mistakes. Its gravity is weaker than Earth's, but still present. Its surface offers no protection, no atmosphere to slow descent, only engines and judgment. When humans finally stepped onto the surface, they did not rush. They moved slowly, deliberately. The moon did not feel distant. It felt quiet, empty. Still, standing on the moon, astronauts were farther from Earth than any human had ever been. And yet, Earth was still visible, a small, bright disk hanging in the sky. This constant presence softened the sense of distance. Earth was far, but not lost. Communication delays were noticeable, but manageable, about 1.5 seconds each way. Conversation required patience, but connection remained. The moon, for all its distance, still felt reachable. And that feeling matters, because it shaped how we remember the journey. The moon feels like a bold leap, but it was also a careful one. Every Apollo mission was designed with return in mind. Landing sites were chosen for safety. Stay durations were limited. There was no intention to remain. The moon was a destination, not a home. And after a few short years, humans stopped going. Between 1969 and 1972, 12 humans walked on the moon. They explored briefly, collected samples, set up instruments. Then they left. No human has returned since. This fact often surprises people. We went to the moon, and then we didn't. The reasons are complex: cost, risk, shifting priorities. But there is also a quieter reason. The moon represents a threshold. Beyond it, everything becomes harder. The moon is close enough to reach and return with careful planning. Beyond the moon, return becomes uncertain. Mars is months away. Communication delays stretch. Rescue becomes impossible. The moon is the last place where Earth still feels present, where help feels imaginable, where home, though distant, still feels real. This is why the moon remains the farthest destination humans have reached, not because we lacked imagination, but because the next step requires a different level of commitment. Standing on the moon, humans were not deep in the universe. They were standing on a nearby neighbor, a stepping stone, but one we never stepped beyond. And yet, even without going farther, the moon revealed something important. Distance is not just about kilometers. It is about separation. On the moon, Earth becomes an object, a single place. No borders, no divisions, just one world, holding everything we know. This perspective is perhaps the greatest distance we traveled. Not outward, but inward. A shift in how we see ourselves. The moon did not take us far into space, but it took us far enough to realize how close we still were. And beyond the moon, there was one moment when humans went even farther, not by landing, not by exploration, but by trajectory. A moment defined by necessity rather than intention. The farthest humans have ever been did not happen on the lunar surface. It happened in the space beyond it. The farthest humans have ever been. When people imagine the farthest place humans have reached in space, they often picture footprints on the moon, a flag standing still, a distant horizon, a moment frozen in history. But the truth is quieter. The farthest humans have ever been was not on the moon's surface. It was beyond it, not as part of a planned exploration, but as the result of necessity. A moment when distance was not the goal, but the consequence. This moment occurred during Apollo 13. Unlike the other Apollo missions, Apollo 13 was never meant to set records. It was intended to land on the moon, complete its tasks, and return home. Routine, by Apollo standards, but space does not always allow routine. 2 days after launch, while traveling toward the moon, an oxygen tank exploded. The sound was brief. The consequences were not. Power was lost. Life support systems were compromised. The mission changed instantly. Landing was no longer possible. Survival became the objective. In the vast emptiness between Earth and Moon, The crew faced a simple truth. They could not turn around easily. Fuel was limited. Energy was scarce. The safest path home was not back the way they came. It was forward. The spacecraft would continue toward the moon, loop around it, and use the moon's gravity to sling itself back toward Earth. This trajectory is known as a free return path. It requires precision and patience, but it also has an unexpected consequence. It takes you farther from Earth than any other path humans have flown. As Apollo 13 approached the moon, the spacecraft passed behind it. For a brief time, communication with Earth stopped entirely. The moon blocked radio signals. No voices, no instructions, no reassurance. The crew was alone. This moment marked the greatest separation between humans and their home planet. At its farthest point, Apollo 13 reached a distance of about 400,171 kilometers from Earth. Farther than any landing mission, farther than any planned journey. This remains, to this day, the record. No human has ever been farther from Earth. What makes this distance remarkable is not the number itself. It is the context. This farthest point was not celebrated. There were no photographs taken for history, no time to reflect. The crew was conserving power, working quietly, thinking carefully. Distance became something to endure, not admire. From this point, Earth was no longer a dominant presence. It was a bright object, but small, a reference point, not a backdrop. And beyond Earth, there was nothing. No stars rushing past, no visual markers of movement, just silence. The farther you go into space, the less it feels like travel. There is no sensation of speed. The mind has nothing to compare against, only numbers and time. This kind of distance is psychologically different. In orbit, Earth feels close enough to protect you. On the moon, Earth feels distant, but comforting. At the far point of Apollo 13, Earth felt fragile, small, irreplaceable. This realization has been described by astronauts who later reflected on the mission. They spoke not of fear, but of clarity, a sudden understanding of how isolated humanity truly is. Everything we depend on exists on a single planet, hanging quietly in space. At that distance, return was not guaranteed. The spacecraft was damaged. Power was limited. The crew lived in a lunar module, never meant to sustain them for long. Temperatures dropped. Water was rationed. Sleep was difficult. And yet, they continued. Slowly, carefully, the moon's gravity did its work. The spacecraft curved around and began the long journey back. From the farthest point, distance no longer increased. It only decreased. Earth slowly grew again, not quickly, not dramatically, but steadily. The crew did not rush. They could not. Everything had to be calculated. Every correction measured. Eventually, after days of uncertainty, they returned safely. Apollo 13 is remembered as a failure and a success. A failure of mission objectives, a success of survival. But it is also something else. It marks the edge, the outermost boundary of human travel. Since that moment, no human has gone farther. Not because we forgot how, not because we lack technology, but because distance demands commitment. Beyond the moon, there is no easy return. Mars, even at its closest, is tens of millions of kilometers away. Travel takes months. Communication delays stretch into minutes. Rescue becomes impossible. Apollo 13 showed us something important. Even at just 400,000 kilometers, space becomes unforgiving. Life support margins shrink. Errors magnify. Every system matters. Human presence, beyond this distance, is not impossible, but it is fragile. This fragility explains something puzzling. Why, after reaching the moon, after setting foot on another world, did humans stop going farther? The answer is not a lack of curiosity. It is respect. Respect for distance. Respect for isolation. Respect for how thin the line is between exploration and disaster. Apollo 13 did not scare humanity away from space. It taught us caution. It reminded us that space does not reward boldness alone. It rewards preparation, patience, redundancy, and even then, nothing is guaranteed. This is why, when we ask how far humans have gone into space, the answer is both impressive and humbling. We have gone far enough to see Earth as a small world, far enough to realize how dependent we are on it, but not far enough to leave it behind. The farthest humans have ever been was a place they never meant to reach, a point defined by survival, not discovery. And perhaps that is fitting, because human exploration of space has never been about conquering distance. It has been about understanding limits. Where our technology ends, where our biology struggles, where Earth's influence fades, but never fully disappears. From that farthest point, humans turned back, not in defeat, but in recognition that distance is not just a challenge, it is a responsibility. And after that moment, human spaceflight would change direction, not outward, but inward, back toward Earth, back toward orbit, back toward what felt manageable. Machines would go farther, signals would travel farther, but humans would remain close to home. And in the quiet space beyond the moon, the edge of our reach remains, unchanged, waiting. Silence between Earth and moon. Between Earth and the moon, there is more than empty space. There is silence. Not the sudden silence of a room going quiet, but a deep, steady, unbroken stillness. This region of space does not announce itself. There are no markers, no borders, no signs that say you have arrived. It is simply there, a vast stretch where familiar sensations fade and new ones never fully appear. For astronauts traveling beyond Earth orbit, this silence is one of the most profound changes. In low Earth orbit, sound is constant. Fans hum, systems click, voices arrive instantly from mission control. Earth feels present, but as a spacecraft moves outward, something subtle happens. The voices begin to pause, not because anyone stops speaking, but because distance introduces delay. Radio waves, which travel at the speed of light, still need time. At first, the delay is barely noticeable, a fraction of a second. But as the spacecraft continues, the pause grows. 1 second, then 2. Conversation changes. Words no longer overlap. Replies arrive gently. After a moment of waiting, this delay is small, but meaningful. It signals separation. It tells the mind that home is no longer immediate. Beyond a certain distance, the spacecraft enters a region where Earth's presence weakens. not just physically, but psychologically. The moon's orbit lies well outside low Earth orbit and beyond much of Earth's protective magnetic field. Here, the environment becomes more exposed. Cosmic radiation increases. Solar particles pass freely. The spacecraft becomes a small island of life, moving through an indifferent sea. This is where silence becomes noticeable. Not total silence. Machines still operate. Breathing is still audible. But external silence. No wind, no weather, no background motion, just the steady hum of systems and the awareness of distance. Astronauts have described this silence as calming and unsettling. At the same time, calming because nothing demands attention, unsettling because nothing responds. In this region, the universe does not react. You move, and nothing acknowledges it. You exist without feedback. This lack of feedback changes perception. Time feels different. Minutes stretch. Hours blur. Without day and night. Without gravity. Without familiar cues. The mind must create its own structure. Astronauts rely on schedules, checklists, and routine, not just for efficiency, but for stability. The silence between Earth and Moon reveals how much of human experience is shaped by surroundings. On Earth, we are constantly responding. Noise, movement, interaction. In deep space, there is only presence. This presence can feel meditative. Thoughts slow. Attention narrows. The mind becomes inward. This is why many astronauts report unexpected moments of reflection. Looking out the window, watching Earth shrink. There is little else to do. The view does not change quickly. Stars remain fixed. Space does not rush. In this stillness, distance becomes real. Not through numbers, but through feeling. Earth, once dominant, now occupies a small portion of the view. The moon, still distant, appears unchanged. Between them, nothing. This emptiness is not frightening, but it is revealing. It shows how isolated human life truly is. Everything we know exists in pockets, planets, moons, stations. Between them, space remains empty. The silence also affects communication in another way. When signals are delayed, decisions must be made locally. Mission control cannot react instantly. Astronauts must think ahead, anticipate, plan for moments when guidance will arrive too late. This responsibility weighs differently. In orbit, support feels immediate. Between Earth and Moon, autonomy becomes necessary. This shift marks a boundary, not of distance, but of independence. Human crews beyond Earth orbit must rely on themselves. This realization influenced how missions were designed. Apollo spacecraft carried detailed procedures, redundant systems, manual backups. Astronauts trained extensively, not just for tasks, but for problem solving. Because once they entered this silent region, help was not immediate. This silence was most intense when the spacecraft passed behind the moon for several minutes, sometimes longer. Communication ceased entirely. The moon blocked radio signals. No messages could pass. No voices could be heard. This blackout was expected, but still powerful. For the first time, humans were completely cut off. No contact with Earth. No reassurance. Just the crew, the spacecraft, and the moon. This moment marked the deepest isolation humans have experienced. Even during Apollo 13, this blackout occurred. While the crew faced uncertainty, it was not dramatic. There were no alarms at that moment, just quiet, waiting, trusting the trajectory, trusting the calculations, trusting that communication would return. When signals resumed, there was relief, but also a subtle change. Earth felt farther, not because of distance, but because of vulnerability. Silence had revealed something. That connection is not guaranteed. That presence can disappear. That space does not provide comfort. It provides opportunity and indifference in equal measure. As astronauts moved away from Earth, the silence became a teacher. It taught patience. It taught attention. It taught respect. This region between Earth and Moon is not empty in a scientific sense. Gravitational forces interact. Particles move. Radiation flows. But to human perception, it feels empty. And that emptiness matters. It is the first place where humans truly feel the scale of space. Not through vast distances, but through lack of interaction. Nothing responds. Nothing changes quickly. Nothing cares. This is why, despite the triumph of reaching the moon, this silent journey left a lasting impression. It revealed that space is not an extension of Earth. It is a different state of existence, one where life must bring everything with it: air, water, heat, connection. Without these, space offers nothing. This understanding shaped what came next. After the moon, human spaceflight did not continue outward. We returned to orbit, to proximity, to places where silence could be broken quickly, where Earth could still answer. The silence between Earth and Moon remains a boundary, a reminder. That distance is not just about how far you travel, but about how alone you become. And as we drift quietly here, in this imagined space between worlds, it becomes easier to understand why humanity paused, why we turned back, why we chose to stay close, even after proving we could go farther. Because beyond this silence, the universe does not change. Only we do. After the moon, why we stopped. After humans returned from the moon, there was no dramatic ending, no declaration that exploration was complete, no final announcement that the journey outward had failed. There was only a gradual slowing. The rockets were still there. The knowledge still existed. The capability largely remained. And yet, the outward momentum faded. This raises a question that has lingered for decades. If humans reached the moon, if we proved it was possible, why did we stop? The answer is not simple. It is not one reason, but many, and most of them are quiet. During the Apollo era, space exploration was driven by urgency, competition, national pride, a desire to demonstrate capability. The moon was a clear target. It was visible, defined, achievable, within a human lifetime. Once that goal was reached, the urgency dissolved. There was no next destination that felt as clear or as close. Mars was discussed, but Mars is different. The moon is days away. Mars is months. Communication delays stretch into minutes. Rescue becomes impossible. Return is not guaranteed. The leap from Earth orbit to the moon was large. The leap from the moon to Mars is far larger. This difference matters. It changes everything. Cost increased dramatically. risk multiplied. Mission timelines extended beyond political cycles, beyond budgets, beyond certainty. Space agencies began to ask harder questions. What is the purpose? What is the benefit? What is the acceptable risk? These questions did not have simple answers. At the same time, another realization became unavoidable. Human bodies struggle in space. Even in low Earth orbit, extended missions take a toll. Bones lose density, muscles weaken, vision changes. The immune system alters, radiation exposure accumulates. These effects can be managed, but not eliminated. Beyond Earth's magnetic field, radiation becomes a serious threat. Cosmic rays pass freely. Solar storms can deliver dangerous doses. In a short time, shielding helps, but adds mass. Mass increases fuel requirements. Fuel increases cost. Every solution creates another problem. Apollo missions were short by design. Days, not months. They minimized exposure. Mars missions would not. They would require long-duration travel, extended stays, and a long journey home. The human body is not well adapted to this. And while technology can compensate, it cannot fully replace biology. This biological reality influenced decisions more than most people realize. Space exploration is not just an engineering challenge. It is a human one. Another factor was sustainability. Apollo missions were expensive. Extremely expensive. They required massive rockets, specialized infrastructure, and a vast workforce. Once the political motivation faded, maintaining that scale became difficult. Public interest shifted. Budgets tightened. Other priorities emerged. Space exploration did not end, but it changed direction. Instead of going farther, we went longer. Longer missions in orbit, more research, more focus on understanding the human body in space before pushing outward again. This shift led to space stations, places where humans could live and work for extended periods while remaining close to Earth. Orbit became a laboratory, not a launch pad. This choice was pragmatic. Low Earth orbit offered safety. Communication was instant. Resupply was possible. Emergency return, though still risky, was conceivable. These factors mattered. After the Moon, space agencies became more cautious. Not fearful, but deliberate. Apollo had shown what was possible. It had also shown how fragile success could be. Apollo 1, Apollo 13, each reminder that risk was ever present. Pushing farther would magnify that risk. Another subtle reason humans stopped going farther was perspective. Seeing Earth from space changed how we think. The overview effect, reported by astronauts, shifted priorities. Earth appeared finite, delicate, worth protecting. This realization encouraged inward reflection. Environmental awareness grew. Global cooperation gained importance. Space exploration became less about conquest and more about understanding. This shift did not cancel exploration, but it reframed it. Robots could go farther with less risk. Probes could travel for years without life support. They could survive radiation. They did not require return. Machines became the explorers of distance. Humans became the explorers of presence. This division made sense. Voyager probes could travel beyond the solar system. Mars rovers could operate for years. Satellites could study distant worlds. Meanwhile, humans remained close to Earth. learning how to live in space rather than how to cross it. This was not failure. It was a pause, a reassessment. Space is not forgiving. It does not reward impatience. The decision to stop going farther was not a retreat. It was recognition that distance is expensive in every sense. Financially, physically, psychologically, distance separates not just bodies, but systems. The farther you go, the more you must carry with you. Air, water, food, power, redundancy upon redundancy. At some point, the spacecraft becomes a small world, and maintaining a world is harder than visiting one. After the moon, humanity chose to build worlds in orbit. Small ones, temporary ones. Places to learn, places to prepare. But preparation takes time, and time, in space exploration, moves slowly. Decades passed. Technology improved. Computers became smaller. Materials became lighter. But the fundamental challenges remained. Distance did not shrink. Space did not become less empty. And Earth did not become less necessary. This is why, when people ask why humans stopped going to the moon, or why we have not gone farther, the answer is not disappointment. It is patience. Human exploration is not linear. It advances, pauses, reflects, and advances again. The moon was a milestone, not a destination. But milestones do not tell you where to go next. They tell you how far you've come. After the moon, humanity chose to consolidate, to understand, to refine, to stay close. And while humans remained near Earth, something else continued. Our machines kept going. They carried our questions, our instruments, and our curiosity far beyond where humans could survive. If humans stopped at the moon, our reach did not. And that reach would travel much farther than any human ever has. Robots go where humans can't. When humans stopped going farther into space, exploration did not stop. It simply changed form. Instead of sending bodies, we sent instruments. Instead of life support, we sent antennas. Instead of oxygen, we sent patience. Robots became our travelers. They did not need air. They did not need food. They did not fear radiation, or silence, or distance. They could wait, and space rewards waiting. The first robotic explorers were simple by today's standards. Small probes, limited power, short lifespans. But even these early machines could go where humans could not. They were not constrained by return. Once launched, they kept going, past the moon, past Mars, past the outer planets, farther than any human could survive. These machines changed our understanding of how far humanity has reached. Because while humans stayed close to Earth, our presence, in a sense, did not. One of the most remarkable examples is the Voyager missions. Launched in 1977, Voyager 1 and Voyager 2 were not designed to last decades. They were built for a grand tour of the outer planets: Jupiter, Saturn, Uranus, Neptune, and then they were expected to fade. But they did not. They continued. They kept traveling, powered by the slow decay of radioactive material. No fuel tanks, no refueling, just steady, patient motion As they passed each planet, they sent back images. Cloud bands on Jupiter, rings of Saturn, icy moons, volcanic worlds, unexpected complexity. These discoveries reshaped planetary science. And then, the Voyagers did something extraordinary. They kept going, beyond the planets, beyond the Kuiper Belt, toward interstellar space. Voyager 1 eventually crossed what scientists consider the boundary of the Sun's influence. It entered interstellar space, a region between stars. No human has ever come close to this distance. Voyager 1 is now more than 24 billion kilometers from Earth. Radio signals take over 22 hours to travel one way. When we speak to Voyager, we wait nearly 2 days for a response. This delay alone marks a separation far beyond human reach. And yet, Voyager still listens, still responds, still sends back data from a place no human could survive. This raises an interesting question. If our machines have gone so far, have we gone there too? In one sense, yes. These machines carry our designs, our instruments, our questions. They are extensions of human curiosity, but they do not carry our presence. No human consciousness, no awareness, no experience. Distance without experience is different. When humans ask, "How far into space have we gone?" they often mean presence, not reach. Robots extend our reach, but they do not extend our lives. This distinction matters because robotic exploration is efficient, but detached. It gathers data, but it does not feel awe. It does not reflect. It does not return with stories. Humans do. This is why, even as robots go farther, the question of human distance remains open. Beyond Voyager, many other machines have traveled far. New Horizons flew past Pluto, revealing a complex world where once we saw a point of light. Pioneer probes drift silently, still moving outward. Mars rovers roam a planet humans have never touched. Satellites orbit distant worlds, mapping, measuring, observing. These machines operate in environments that would kill humans quickly. Extreme cold, radiation, vacuum, time spans measured in decades. They do not complain. They do not tire. They simply continue. In this way, human exploration has become divided. Machines handle distance. Humans handle presence. Robots scout. Humans observe from afar. This division is not permanent, but it is practical. Distance in space scales rapidly. The farther you go, the harder it becomes to support life. Robots do not need life support. They do not need return tickets. They can be abandoned without moral consequence. Humans cannot. This is why, when space agencies plan missions beyond the moon, robots lead the way. They test environments, measure radiation, assess resources. They prepare the path without requiring commitment. And yet, robots cannot replace everything. They cannot respond intuitively. They cannot improvise with understanding. They cannot experience. This limitation becomes important when considering future human missions. Mars, for example, has been visited by dozens of robotic missions. We know its surface better than many places on Earth, but no human has been there. Distance is not the only barrier. Presence matters. Still, for now, robots are our ambassadors. They travel farther than we can. They send back whispers from the edge. They remind us how small we are and how far space extends. Voyager carries something else. A golden record. A message. Images of Earth. Sounds. Music. Greetings in many languages. It was not sent for aliens. It was sent for time. A way of saying, this is who we were. This object, now drifting between stars, is the farthest human-made artifact. But it is not human. It does not think. It does not remember. It does not know where it is going. It simply moves, forever. This is how far our machines have gone. Farther than any human, farther than any living thing from Earth. And yet, this distance feels abstract, because no one has been there. No one has looked back from that place and seen Earth. Distance without awareness is impressive. Distance with awareness is transformative, and that remains rare. As robots continue outward, they redefine reach, but not presence. They remind us that space is vast and that life is fragile. They show us how far curiosity can travel without bodies, and in doing so, they quietly emphasize something else. That the question of how far humans have gone into space is not answered by kilometers. It is answered by experience. By where we have lived, where we have stood, and where we have looked back and seen Earth. So far, that list remains short. Orbit. The moon. A single distant trajectory beyond it. Everything else belongs to machines. And as they continue their silent journey, we remain, watching, learning, and waiting. How far have our signals gone? While human bodies remained close to Earth and machines traveled outward, something else moved even farther. Something weightless, invisible, silent. Our signals. Every time humanity spoke into the sky, a message left the planet. Not in rockets, not in capsules, but as waves of energy moving outward at the fastest speed possible, the speed of light. Long before humans reached space, Earth began broadcasting itself. Radio waves spilled outward in expanding spheres. Early transmissions were unintentional. Television signals, radar pulses, military communication. They were never meant to travel far. They were meant to bounce, to reflect, to return. But radio waves do not stop at the edge of the atmosphere. They do not slow down. They do not ask permission. They continue forever. Unless something stops them. Nothing did. So Earth began to glow, quietly, in radio light. This glow forms what scientists call the radio bubble, a growing sphere of signals, centered on Earth, expanding at the speed of light. Every year, this bubble grows by 1 light year, not because we push it, but because light never rests. As of now, human radio signals have traveled more than 100 light-years into space. That means any civilization within that radius, with the right technology, could theoretically detect Earth. They would not see our cities. They would not see us. They would hear us. Fragments of broadcasts, snippets of voices, patterns of radar, echoes of a young technological world. This raises an interesting contrast. Human bodies have traveled about 400,000 kilometers from Earth. Our machines have traveled billions of kilometers, but our signals have traveled trillions upon trillions. They have passed nearby stars. They have crossed regions of interstellar space. They have outpaced everything else we have sent. In this sense, humanity's presence extends much farther than our physical reach. But this presence is faint. Radio signals weaken as they spread. They disperse. They blend into background noise. By the time they reach distant stars, they are whispers, difficult to distinguish, easy to miss. This subtlety matters, because while our signals have gone far, they do not announce us loudly. They do not declare arrival. They simply drift, and they do not carry intention. Most of our signals were never meant to represent humanity. They were incidental, side effects of communication. Earth was not waving. It was talking to itself. Occasionally, humans chose to send deliberate messages, powerful radio transmissions, aimed at specific star systems. Simple information, mathematics, images, coordinates. These messages were not conversations. They were introductions, a way of saying, someone is here. But even these messages are small and slow compared to the scale of space. A targeted message may reach its destination in decades. A reply, if any, would take decades more. Communication across interstellar distances is measured in generations. This creates a profound limitation. Even though our signals travel fast, space is larger. Light speed feels instantaneous. On Earth, across continents, signals move instantly. Across the solar system, they take minutes. Across interstellar space, they take years. Across the galaxy, they take tens of thousands of years. This reality reframes the idea of distance. We often imagine the universe as something we can reach, if only we try harder. But the universe operates on timescales that dwarf human lives. Our signals may reach distant stars. Long after we are gone, they may be received by civilizations that no longer exist, or by none at all. This uncertainty is part of the story. When we ask how far humans have gone into space, signals complicate the answer. They are not human. They do not think. They do not observe. But they originate from us. They carry traces of our activity. In this way, humanity extends outward without moving. Earth becomes a lighthouse, not bright, but persistent. Its radio glow expands, year by year, marking the passage of time. This glow is not uniform. It reflects our technological history. Early radio signals were powerful, but simple. Later, signals became weaker, but more complex. As technology changed, Earth's radio signature changed. Modern communication is more efficient, more directed, less wasteful. Ironically, this makes Earth quieter, harder to detect. Our early radio years may be the loudest we ever were. This adds another layer of irony. The moment we became technologically capable was the moment we were most visible. As we advance, we may become less noticeable. This means that Earth's radio bubble is not a perfect record. It fades. It disperses. It becomes background. Still, it travels, passing star systems, one by one, carrying no awareness, no intention, just evidence. This invisible expansion contrasts sharply with human exploration. Bodies require life support. They require return paths. Signals require nothing. They move freely. This freedom highlights the difference between reach and presence. Signals reach far. Presence remains close. And yet, signals shape how we think about space. They remind us that humanity is not confined to Earth's surface. Our influence, in some form, extends outward, not as explorers, not as settlers, but as noise. This noise may never be heard. Or it may be the first thing another civilization notices, a faint pattern in the static, a sign that somewhere a technological species exists or existed. From a human perspective, this raises philosophical questions. Have we already announced ourselves? Have we already left Earth? In some abstract sense, if a signal arrives at a distant star, long after Earth has changed, what does that represent? A moment frozen in time, a snapshot, a ghost. This is why signals feel different from spacecraft. Spacecraft can be tracked. They exist. They have locations. Signals, once sent, cannot be recalled. They continue, regardless of what happens next. They represent commitment without control. In this way, signals are the boldest thing humanity has done, not because they travel far, but because they cannot return. And yet, despite their reach, signals do not satisfy the question. Because when people ask, how far into space have humans actually gone? They are rarely asking about radio waves. They are asking about experience, about where humans have lived, breathed, and looked back at Earth. Signals do none of these things. They extend presence, but not consciousness. They mark distance, but not understanding. So while our signals drift outward, marking time and existence, humanity remains near home, watching, listening, waiting. And as we consider how far our voices have gone, another question emerges. Not how far, but how fast. Because distance is not the only barrier. Time is equally powerful. And space exploration is shaped as much by time as by distance, a destination we haven't reached. When people imagine the future of human space exploration, one destination appears again and again: Mars. Not because it is close, not because it is easy, but because it feels possible. Mars has fascinated humanity for centuries. It is visible to the naked eye. It changes brightness. It moves against the background of stars. It feels alive, in motion, and within reach. And yet, no human has ever been there. To understand why, we need to slow down and look at Mars not as a symbol, but as a place. Mars is not always close. Its distance from Earth changes constantly. Sometimes it is relatively nearby. Sometimes it is very far away. This depends on where both planets are in their orbits around the Sunday. At its closest, Mars is about 56 million kilometers away. At its farthest, it is more than 400 million kilometers distant. Even at its closest, Mars is vastly farther away than the Moon. The Moon is a few days away. Mars is months. Traveling to Mars is not a straight line. Spacecraft must follow curved paths, guided by gravity and efficiency. These trajectories take time. Typically, a journey to Mars takes about 6 to 9 months. That is just one way. Return requires waiting. Planets must align again. This means a crew sent to Mars would likely spend years away from Earth. Not days, not weeks, years. This duration changes everything. Short missions can rely on stored supplies. Long missions require sustainability. Air must be recycled, water reused, food carefully managed. Every failure compounds over time. Every delay matters. Communication adds another layer of complexity. Mars is far enough away that radio signals take time. At best, about 4 minutes one way. At worst, more than 20 minutes. This means real-time conversation is impossible. Mission control cannot guide astronauts through emergencies. Decisions must be made locally. Autonomy becomes essential. This distance also affects psychology. Humans are social beings. We rely on interaction, on immediacy, on response. Extended isolation with delayed communication creates stress. Even in orbit with constant contact, missions are challenging. Mars magnifies this challenge. Then there is radiation. Beyond Earth's magnetosphere, astronauts are exposed to cosmic rays. These high-energy particles damage DNA. They increase cancer risk. They affect the nervous system. Mars missions expose crews to this radiation for long periods. Shielding helps, but shielding adds mass. Mass increases fuel requirements. Fuel increases cost. Every solution carries trade-offs. Mars itself is not welcoming. Its atmosphere is thin, too thin to breathe, too thin to protect from radiation. Temperatures are cold. Dust storms can last for months. Water exists, but mostly as ice. Living on Mars would require sealed habitats, pressurized suits, constant maintenance. Mars is not a backup Earth. It is a challenge. So why consider it at all? Because Mars is the most Earth-like planet we can realistically reach. It has a day similar in length to ours. It has seasons. It once had flowing water. It holds clues about planetary evolution and possibly life. Robotic missions have revealed much. Rovers have traveled across its surface. They have drilled into rock, analyzed soil, taken panoramic images. We know Mars better now than ever before. But robots do not replace humans. They move slowly. They are limited. They cannot adapt quickly. Human presence would accelerate discovery, but at a cost. A Mars mission would be the first time humans truly leave Earth behind. No easy return, no immediate help, no quick rescue. It would be a one-way commitment. For years, this level of separation is unprecedented. Apollo missions had backup plans. Orbit missions have escape routes. Mars has neither. If something fails, the crew must survive. Or not. This reality weighs heavily on mission planning. It is not enough to reach Mars. The crew must arrive healthy. They must function effectively. They must return. Each phase is complex. Together, they form a system with little margin for error. This is why, despite decades of discussion, humans have not gone to Mars. Not because of lack of interest, not because of fear, but because Mars requires a different approach. One that blends engineering, biology, psychology, and patience. Mars demands long-term commitment, and humanity has been cautious. This caution is not weakness. It is understanding. Understanding that distance is not just spatial. It is temporal. Mars is far not because of kilometers alone, but because of time. Time away from Earth. Time exposed to risk. Time without immediate support. These factors combine to create hesitation. Yet, The idea of Mars persists. Plans are made, concepts refined, technologies tested, habitats designed, life support systems improved, robotic missions scout landing sites. Every step is deliberate, slow, measured. Mars is not a race. It is a test of readiness, of whether humanity can sustain itself away from Earth for long periods. So far, the answer remains uncertain, and until that uncertainty is resolved, humans remain where they are, close to home, learning, preparing. Mars waits. Not impatiently, not dramatically. It has waited billions of years. It can wait longer. And as we look outward, toward that distant red point in the sky, it reminds us of something important. Human exploration does not advance because we want it to. It advances when we are ready. And readiness, in space, is measured not in ambition, but in endurance. Why distance is the real enemy. When we think about space exploration, we often imagine obstacles: heat, cold, radiation, vacuum. These dangers feel dramatic. They sound like enemies, but none of them are the true barrier. The real enemy is distance. Distance changes everything. On Earth, distance can usually be solved. Roads connect cities. Aircraft cross oceans. Ships travel for weeks and still arrive safely. But space does not scale this way. Every kilometer away from Earth increases complexity, not gradually, but exponentially. Distance in space demands fuel. Fuel has mass. Mass requires more fuel. This creates a cycle. To go farther, you must carry more. To carry more, you must burn more. At some point, adding fuel no longer helps. It hurts. This is known as the rocket equation, a simple concept with profound consequences. Each additional unit of mass requires disproportionately more fuel. This is why spacecraft are designed to be as light as possible. This is why missions are planned carefully. And this is why distance resists us. On Earth, adding fuel usually extends range. In space, it often limits it. Distance also affects time. Travel in space is not fast, by human standards. Even at tremendous speeds, the universe is large. The moon takes days. Mars takes months. Beyond that, years. During this time, life must continue. Air must be recycled, water purified, food preserved. Every system must operate continuously, without failure. On Earth, failure can be repaired quickly. In space, failure compounds. A small leak becomes critical. A broken pump becomes life-threatening. Distance removes redundancy. You cannot call for parts. You cannot wait for help. You must solve problems with what you have. This reality shifts how missions are designed. Spacecraft are not built for comfort. They are built for survival. Every component is chosen carefully. Every backup is weighed against mass. Every added system introduces new failure points. Distance forces trade-offs. Biology adds another layer. The human body evolved on Earth. Gravity shapes our bones. Our muscles, our circulation, remove gravity, and the body adapts, but not perfectly. Muscle atrophy begins quickly. Bone density decreases. Vision can change. Balance is disrupted. These changes can be managed for short periods, But over months, they become serious. Distance lengthens exposure. The farther you go, the longer you must endure. Radiation exposure accumulates. Cosmic rays damage cells. Solar events can deliver dangerous doses suddenly. Earth's magnetic field protects us. Distance weakens that protection. Beyond Earth, radiation becomes relentless. Shielding helps, but shielding adds mass. Mass increases fuel needs. Again, distance resists. Psychology is equally affected. Humans are adapted to environments with variety, changing scenery, social interaction, natural cues. Space offers none of these. The farther you go, the fewer reference points remain. The view out the window changes slowly, or not at all. Earth shrinks, then disappears. Mars grows, then dominates. Between them, there is nothing. This monotony affects the mind. Time perception changes. Stress accumulates. Small conflicts grow larger. Distance amplifies isolation. In low Earth orbit, astronauts can see Earth daily. They can speak with loved ones in real time. They can return quickly if needed. Distance removes these comforts. Mars missions would involve months without seeing Earth clearly. Delayed communication. No possibility of early return. This level of isolation has never been experienced by humans. It introduces unknowns, and space exploration is cautious with unknowns. Distance also affects energy. Solar power weakens as you move away from the Sunday. Systems must adapt. Batteries must store more. Nuclear power becomes attractive, but introduces complexity and risk. Everything about space systems becomes harder with distance. Navigation changes too. In orbit, position is well understood. In deep space, navigation relies on calculations. Small errors grow. Course corrections require fuel. Fuel is limited. Distance magnifies mistakes. Even communication itself is shaped by distance. Signals take time. At Mars, minutes. Beyond, hours. Eventually, days. This delay affects decision-making. Autonomy becomes essential. Human crews must operate independently. This independence is empowering, but dangerous. Errors cannot be corrected quickly. Misjudgments linger. Distance removes safety nets. All of these factors combine to create resistance. Not dramatic resistance, quiet resistance. Space does not fight you. It simply does not help. It offers no shortcuts, no efficiencies, no mercy. Every additional kilometer requires commitment. This is why humanity's outward journey has been incremental. Orbit first, then the moon, then a pause. This pause is not stagnation. It is adaptation. Humanity is learning how to manage distance, how to design systems that can operate for years, how to support life sustainably, how to make decisions without immediate support. These lessons take time. Distance demands patience. This is why, despite our imagination, humans have not rushed outward. The universe is not impressed by ambition. It responds only to preparation. Distance also reframes success. Reaching a place is not enough. You must survive there. You must function. You must return, or choose not to. Distance forces clarity. It strips exploration down to essentials. This clarity explains why robotic missions have advanced faster. Robots do not suffer isolation. They do not age. They do not fear distance. They operate within constraints, but they do not experience them. Humans do. This is why, when asking how far humans have gone into space, the answer is modest. Because presence is expensive, experience is costly, and distance multiplies cost. But this modesty should not be mistaken for failure. It reflects understanding. Human exploration is not about pushing limits blindly. It is about expanding sustainably. Distance has taught us humility. It has reminded us that Earth is not just a starting point. It is a lifeline. Every mission carries Earth with it. In systems, in biology, in culture, the farther we go, the harder it becomes to maintain that connection. And yet, distance also invites possibility. It challenges us to rethink how we explore, how we live, how we define presence. Perhaps future exploration will not look like Apollo. Perhaps it will be slower, more modular, more distributed. Distance may be conquered not by speed, but by patience, not by single journeys, but by sustained presence. For now, distance remains the boundary, the quiet, persistent, unforgiving barrier. And understanding it is the first step toward eventually moving beyond it. Space is bigger than we imagine. Even after understanding distance, after learning how fuel, time, and biology resist us, there is still something we struggle to grasp. Scale. Not emotional scale. Not conceptual scale. Actual size. Space is not just large. It is larger than intuition allows. Our minds evolved on a planet where distances are familiar. We measure journeys in steps, in hours, in days. Even the largest distances on Earth are manageable. Oceans can be crossed, continents connected, but space does not behave like Earth. Its scale grows faster than imagination. To understand how far humans have gone, we must first understand how much space there actually is. Let's begin close. The moon feels far. 3 days of travel, nearly 400,000 kilometers. Yet, in the context of the solar system, the moon is barely separated from Earth. If Earth were the size of a marble, the moon would be a small grain of sand, just a few centimeters away. That distance feels manageable. Beyond the moon, the next major destination is Mars. Mars feels reachable, in theory. But place Earth and Mars at scale, and the space between them becomes vast. Even at their closest, there is room for millions of moons to fit between them. This is where intuition breaks. Because the solar system is not arranged like textbook diagrams. Those images compress space. They place planets neatly, evenly spaced, close together. In reality, the solar system is mostly empty. Planets are small. Distances are enormous. If you scale Earth down to a grain of sand, the sun would be several meters away, and the next star would be kilometers distant. This emptiness defines space. Travel between planets is not about navigating obstacles. It is about enduring nothingness. The farther humans go, the longer they travel, without seeing change. Voyager spacecraft illustrate this better than anything. After passing the outer planets, Voyager entered a region with no landmarks, no destinations, just distance. Years passed, with little visual change. Instruments continued to operate. Signals continued to travel back, but visually, space remained the same. This sameness can be misleading. It makes space feel static. But in truth, Voyager was moving faster than any human vehicle had before, tens of thousands of kilometers per hour. Yet even at that speed, it took decades to leave the solar system. This reveals a humbling truth. Human speed, even at its greatest, is slow compared to cosmic distances. The solar system itself is a tiny region within the galaxy. The Milky Way contains hundreds of billions of stars. Each star likely hosts planets. The distances between stars are measured in light years. Light years, a unit defined by time, not space. The distance light travels in 1 year, nearly 10 trillion kilometers. Humans have never traveled even a fraction of a light year. The Moon is a light second away. Mars, a few light minutes. Voyager, a fraction of a light day. The nearest star, over 4 light years away. This gap is difficult to comprehend. If humans traveled to the Moon every day for thousands of years, we would still not reach the nearest star. This is why, when discussing how far humans have gone into space, context matters. The Moon, impressive as it is still part of Earth's neighborhood. It is not interplanetary exploration. In the true sense, it is local. Even Mars remains within the Sun's immediate influence. The heliosphere, a bubble of solar wind, extends far beyond the outer planets. Humans have not left this bubble. Only robotic probes have, and even then, only barely. Voyager's crossing into interstellar space was not marked by spectacle. There was no boundary to cross, no signpost, just a gradual change in particle density. This subtlety is important. Space does not provide dramatic markers. It does not announce transitions. It simply continues. This continuity makes scale hard to feel. We expect milestones, edges, but space offers none. This is why diagrams are misleading. They impose structure where none exists. They suggest closeness where there is separation. The truth is quieter. Planets are isolated. Stars are distant. Galaxies are islands in an even larger emptiness. Understanding this scale reshapes how we view human exploration. It shows why we pause, why we plan, why we move slowly. It is not because we lack ambition. It is because ambition must contend with reality. And reality is vast. When astronauts looked back at Earth from the Moon, they saw a small world. When we look outward from Earth, we see an even larger context, a universe that does not revolve around us. This perspective is not discouraging. It is grounding. It reminds us that presence matters, that being somewhere means more than reaching it. Human exploration has always been intimate. It values experience, touch, observation, reflection. These things do not scale easily. Machines can cross distance. Humans carry meaning. This is why, despite the enormity of space, human journeys have remained close. We explore thoroughly before expanding. We understand deeply before moving outward. This approach contrasts with imagination. Science fiction often depicts rapid expansion, interstellar travel, colonies across galaxies. These stories compress scale. They make the universe feel navigable. Reality is slower, heavier, but also more profound. Because every step outward is significant. Every new environment teaches us something fundamental. Even standing on the moon revealed truths about Earth. Scale magnifies meaning. It turns small achievements into milestones. It turns modest distances into revelations. When we ask how far humans have gone into space, the answer is small and immense. At the same time, small in kilometers compared to the universe, immense in perspective gained. Space is bigger than we imagine, and that realization is part of the journey. It tempers expectation. It encourages patience. It invites humility. And as we continue, we begin to see that the farthest distance humans have traveled may not be measured outward at all. It may be measured inward, in how we understand our place, in how we redefine exploration, in how we choose to proceed, because space does not rush, and neither should we. The farthest human objects, long after humans stopped traveling outward, after bodies returned to Earth and missions settled into orbit, some objects continued. They did not carry people. They did not carry life. They carried momentum. These are the farthest human objects, not destinations, not explorers in the human sense, but artifacts released into the vastness and left to drift. The most famous of these are the Voyager spacecraft, but they are not alone. Before Voyager, there were the Pioneer probes. Pioneer 10 and Pioneer 11 were launched in the early 1970 seconds. Their mission was simple: reach the outer planets, send back data, keep going. At the time, no one knew how long they would last. They were small, lightweight, and limited, yet they exceeded expectations. Pioneer 10 became the first human-made object to pass through the asteroid belt. It traveled to Jupiter, sent back images, and continued outward. Eventually, its signals faded, not because it stopped moving, but because distance weakened communication. Pioneer 10 is still traveling, silently, somewhere in the direction of the constellation Taurus. No one will ever visit it. No one will ever retrieve it. It will drift for millions of years unless something stops it. Pioneer 11 followed a similar path. It passed Jupiter, then Saturn, and continued outward. It too fell silent. But before it did, it left a message. Attached to both Pioneer probes was a small metal plaque, simple, engraved. It showed the outline of a human figure, a map of Earth's location, basic information. It was not a greeting. It was a marker, a quiet statement. Something like, "This came from somewhere." Voyager expanded this idea. Each Voyager carries a golden record, a phonograph disc, covered in gold. On it are sounds of Earth, music, voices, natural noises, images encoded in analog form, instructions on how to play it. This record was not sent with expectation. The odds of it being found are vanishingly small, but that was never the point. The golden record is a time capsule, a way of saying, this is what we were. It drifts now, attached to a machine, moving through interstellar space. Voyager 1, the farthest human-made object, continues outward. It has no destination. It is not aimed at a particular star. It moves in a general direction, defined by the gravity it encountered long ago. At its current speed, It will take tens of thousands of years to pass near another star. Even then, it will not stop. It will not orbit. It will pass quietly and continue. This is what distance looks like. Not a journey with an end, but motion without purpose. These objects redefine what it means to go far. They do not experience the distance. They do not know where they are. They do not reflect. They simply persist. This persistence highlights a contrast. Humans seek meaning in travel. We want destinations, stories, experiences. These objects do none of that. They represent reach without presence, distance without awareness. And yet, they carry something profoundly human: intent, design, choice. They exist because someone decided to send them, to let them go, to accept that they would never return. This acceptance is rare. Most human journeys include return plans. Voyager did not. It was launched with farewell built in. This makes it unique. It is a human creation, designed to outlast its creators. Long after Earth changes, long after cities fade, Voyager will still move. This is both comforting and unsettling. It suggests continuity beyond human time, but it also emphasizes fragility. Because these objects are not us, they are symbols. They represent curiosity without vulnerability. They remind us that distance can be crossed without experience, but experience cannot be replicated without presence. As these farthest human objects drift outward, they leave behind a quiet trail. Not a physical trail, but a conceptual one. They mark how far our tools can go, not how far we can live. This distinction matters, because when people ask, how far into space have humans actually gone? They often conflate the two. They imagine that because Voyager is far, we are far. But humans have never been there. No one has looked back at Earth from interstellar space. No one has felt the isolation of that distance. No one has existed that far from home. The farthest human objects are ambassadors without witnesses. They do not report what they see. They only transmit numbers until they cannot. Then they continue silently. This silence is permanent. No one will hear them again. They will never know if they were successful. And yet, their existence changes something. They extend humanity's footprint beyond biology. They show what persistence looks like without life. They raise philosophical questions. Is presence defined by awareness? Does reach require experience? What does it mean to leave something behind that will outlast you? These questions do not have answers, but they linger, much like the spacecraft themselves. As we imagine these objects drifting far beyond the sun's influence, it becomes clear that humanity's relationship with distance is complex. We send machines outward while we remain close. We extend reach while preserving presence. This balance may change in the future, or it may not. For now, the farthest human objects continue their silent journey, carrying no expectations, no urgency, no destination, just motion. And as they move outward, they quietly underline the truth that humanity's greatest distances have not been traveled by people. They have been traveled by things. And that difference defines how far we have actually gone. Have we actually gone anywhere? After tracing the farthest paths of our machines, after measuring distances in billions of kilometers, after watching objects drift beyond the sun's reach, a quieter question begins to surface. Have we actually gone anywhere? It sounds strange, almost dismissive. After all, humans have left Earth. They have orbited the planet. They have stood on another world. And yet, when placed against the scale of space, these achievements feel small. This feeling is not meant to diminish them. It is meant to contextualize them. Because distance alone does not define exploration. Presence does. When humans first left Earth, they did not travel far. They orbited. They stayed close. They remained within sight and influence of home. Even the journey to the moon, our farthest destination, kept Earth visible, always present, always nearby. This closeness shaped the experience. It softened the distance. It made return feel possible. In contrast, our machines have gone far without presence. They carry no awareness, no memory. They do not witness their own journeys. So, when we say humanity has reached interstellar space, what do we mean? Our tools have, but our bodies and our minds have not. This distinction invites reflection, because exploration has always been about experience, about seeing, feeling, and understanding. Distance without experience is measurement. Experience without distance is perspective. Human spaceflight has prioritized perspective. Seeing Earth from orbit changed how we see ourselves. Seeing Earth from the moon changed how we understand our place. These shifts happen close to home, not far away. This suggests something important. Perhaps exploration is not defined by how far we go, but by what changes within us when we go. From this viewpoint, humanity has traveled a great distance, not outward, but inward. We have learned to see Earth as a single world. We have learned that borders disappear from above. We have learned that our atmosphere is thin and fragile. These lessons came from proximity, not from distance. They came from orbit, not interstellar space. So have we gone anywhere? Yes, but not in the way distance suggests. We have expanded awareness, not territory. We have deepened understanding, not spread presence. This reframing can feel uncomfortable. It challenges narratives of progress. It resists the idea that exploration must always move outward. But space does not reward expansion for its own sake. It rewards meaning. Human missions have been meaningful because they were rare, deliberate, and transformative. Going to the moon once changed how we think forever. Going again might not. Distance is not additive in the way we expect. The first step matters more than the 100th. The first view of Earth matters more than the 1,000th orbit. This is why, despite technological capability, humans did not continue outward rapidly, because repeating the same experience at greater distance does not guarantee new understanding. This does not mean humanity will never go farther. It means that going farther must be purposeful, not just possible. This pause in human expansion can be seen as hesitation or wisdom, as impatience or maturity. It depends on perspective. Space is not going anywhere. The moon will remain. Mars will wait. Interstellar space will still be vast. Humanity does not need to rush. We have learned, slowly, that exploration without readiness leads to loss. And readiness is not just technological. It is psychological, cultural, ethical, Distance forces questions. Who goes? Why? At what cost? For what benefit? These questions have no easy answers. They require time, reflection, consensus. Machines do not ask these questions. They do not need to. Humans do. This is why robotic exploration advanced faster. It bypassed debate. It minimized risk to life. It delivered knowledge efficiently. But knowledge is not the same as understanding. Understanding requires context. And context is human. So when we consider how far humans have gone into space, the answer becomes layered. Physically, we have gone a modest distance. Experientially, we have gone far. Philosophically, we have gone farther still. We have learned humility. We have learned fragility. We have learned patience. These lessons are not measured in kilometers. They are measured in perspective. This may be the most honest answer. Humans have gone far enough to understand how small we are, far enough to realize Earth is not infinite, far enough to know that survival beyond home is not trivial, far enough to appreciate the value of return. This does not mean exploration is complete. It means exploration has meaning. It suggests that future journeys will not be driven by novelty, but by necessity, by curiosity tempered with care, by ambition shaped by understanding, and perhaps this is the most human way to explore. Not to rush outward blindly, but to pause, reflect, and choose carefully. So have we actually gone anywhere? Yes, we have gone far enough to ask better questions, and that may be the greatest distance. We have traveled so far, the illusion of progress. From a distance, human space exploration can appear stalled. Decades pass. Technology advances. And yet, humans remain close to Earth. We orbit. We study. We test. We do not rush outward. To some, this feels like failure, an illusion of progress. Rockets look more advanced. Computers are faster. Materials are lighter, but the destinations remain the same. Low Earth orbit, occasionally the Moon, in planning, not in presence. This contrast creates frustration. Why, with all our knowledge, have we not gone farther? Why does progress feel circular? The answer lies in how we define progress itself. On Earth, progress often means expansion, more territory, more speed, more reach. But space does not reward this mindset. It demands something else: stability, reliability, endurance. Early space exploration advanced rapidly because the problems were clear: reach orbit, survive launch, return safely. Each success unlocked the next challenge. Once these problems were solved, progress slowed, not because curiosity faded, but because remaining challenges were more subtle, harder to see, harder to solve. Living in space for minutes is different from living there for months. Living there for months is different from years. Progress shifted from movement to sustainability. This shift is easy to overlook. It lacks spectacle. It does not produce dramatic headlines, but it is fundamental. The International Space Station is often criticized as repetitive. Astronauts come and go. Experiments repeat. Orbit continues. From the outside, it looks static. From the inside, it is transformative. The ISS is not about going far, It is about staying healthy, staying functional, staying human. Every long-duration mission adds to our understanding of what it takes to survive away from Earth. Bone density studies, muscle preservation, psychological resilience. These are not glamorous topics, but they are essential. Without solving them, distance is irrelevant. This creates the illusion of stagnation. We see rockets launch, but not farther. We hear about plans, but not arrivals. But progress is occurring, quietly, incrementally, in ways that are not immediately visible. Technology improves in layers. Life support systems become more efficient. Recycling improves. Automation increases. Crew autonomy grows. Each improvement reduces risk. Slightly. Over time, these small reductions accumulate. This is how space exploration actually advances. Not through leaps, but through compression of risk. The moon landings were a leap. They were possible because risk was accepted at high levels. Today, risk tolerance has changed. Human life is valued differently. Failures are scrutinized. Accidents carry lasting impact. This does not make exploration weaker. It makes it more deliberate. The illusion of progress also arises from comparison. We compare modern spaceflight to the Apollo era. Apollo happened quickly. In just over a decade, humans went from first orbit to moon landings. This pace feels impossible now. But Apollo was unique. It was fueled by competition, urgency, unlimited resources. By today's standards, it was not sustainable. It was a sprint. What followed was a marathon. Marathons are quieter. They require pacing. They demand consistency. Space exploration after Apollo shifted into marathon mode. This shift does not produce dramatic milestones. It produces stability, consistency, understanding. The illusion of progress is reinforced by popular imagination. Science fiction depicts rapid expansion, starships crossing galaxies, colonies on distant worlds. These stories compress centuries into hours. They create expectations that reality cannot meet. Reality moves slower, but reality is honest. It reveals constraints, and working within constraints is itself progress. Another layer of this illusion comes from automation. As machines take on more tasks, human involvement becomes less visible. Robotic missions succeed quietly. They send data, but not people. This creates the impression that humans are falling behind. In truth, robots are extending our reach. While humans consolidate presence, these paths are complementary, not competitive. Robots map environments. Humans learn how to live. Together, they prepare for future steps. Progress also looks different. When measured over human lifetimes, a decade feels long. A generation feels slow. But space exploration unfolds on longer timescales. Technologies developed today may enable missions decades later. This delayed payoff is difficult to appreciate. It tests patience. It challenges funding. It invites skepticism. But it is how complex systems mature. The illusion of progress also stems from visibility. Failures are visible. Delays are visible. Successes that involve refinement are not. A spacecraft that survives one more year in orbit does not make headlines. But that survival may be crucial. It may inform design decisions. It may prevent future loss. Progress hides in reliability. in repetition, in systems that continue to work. This perspective reframes our understanding. Staying close to Earth is not stagnation. It is groundwork. It is learning how to detach without breaking, how to leave without losing. This groundwork is necessary for any future expansion. Skipping it would be reckless. History shows this. Early aviation advanced rapidly, then slowed as safety became a priority. Commercial flight today is routine because of that slowdown. Space exploration is undergoing a similar transition, from experimental to operational, from heroic to sustainable. This transition feels like a pause, but it is not. It is maturation. The illusion of progress fades when we change our frame of reference. Instead of asking, "How far have we gone?" we ask, "How prepared are we?" The answer is steadily improving. Humanity has not stalled. It has stabilized. And stability is not the end of exploration. It is the foundation. The future of human spaceflight will likely look different from the past. Less dramatic launches, more gradual expansion, long-term habitats, incremental outward steps. These steps will not feel sudden. They will not feel historic in the moment, but in hindsight, they will matter. The illusion of progress comes from expecting spectacle. Reality delivers endurance, and endurance in space is everything. As we move toward the end of this journey, one final perspective remains. Not about distance, not about machines, but about meaning. Because in the end, how far we have gone matters less than why we choose to go at all. What this distance really means, after all the measurements, after the distances counted in kilometers, after the records and milestones, we are left with something quieter. Meaning, because distance alone does not tell the full story. Humans have always measured progress by how far we go, across land, across oceans, into the sky. But space changes that instinct. It asks a different question. Not how far, but why. When humans first left Earth, the goal was simple: survive. Everything else came later. Orbit taught us fragility. The moon taught us perspective. The silence between worlds taught us humility. Each step outward was also a step inward, toward understanding, toward restraint, toward awareness. Distance revealed limits, but it also revealed values. It showed us what we are willing to risk and what we are not. The farther we go, the more clearly Earth matters. This seems paradoxical. Exploration is often imagined as escape, leaving behind, finding something new. But human spaceflight has done the opposite. It has intensified our connection to home. Astronauts often describe a profound attachment to Earth. After returning, not less, but more. Seeing Earth from afar does not diminish it. It concentrates it. All life in one place. All history on one surface. This realization changes priorities. It shifts focus from expansion to preservation. This does not mean exploration ends. It means exploration evolves. Distance becomes something to respect, not conquer. A challenge to understand, not defeat. The fact that humans stopped going farther is often framed as loss, as failure, as wasted potential. But there is another interpretation. choice. Humanity chose to pause, to consolidate, to reflect, to learn. This choice suggests maturity. Early exploration was impulsive, driven by competition, by urgency, by novelty. Modern exploration is intentional, driven by sustainability, by cooperation, by long-term thinking. Distance demands this shift because space is unforgiving. It does not allow shortcuts. It does not reward haste. Every decision echoes across time. This is why, when we consider how far humans have gone into space, the answer feels unsatisfying to some, because it is not dramatic. It does not end with colonization. It does not culminate in conquest. Instead, it ends with awareness, with restraint, with patience. This ending is quiet, but quiet does not mean insignificant. In fact, it may be the most important lesson. Human exploration is not about leaving Earth behind. It is about understanding Earth's place. Distance has shown us that Earth is not replaceable. Not easily, not soon, not ever, in a meaningful way. Mars is fascinating. The Moon is valuable, but neither is home. Distance makes this clear, and clarity shapes decisions. Future missions will happen. Humans will likely return to the Moon. They may eventually reach Mars. But when they do, it will not be because distance was conquered. It will be because distance was understood. Because systems were ready. Because humans were prepared. Not just physically, but psychologically. Distance teaches patience. It stretches timelines. It slows ambition. But it also deepens purpose. The farther away Earth becomes, the more intentional every action must be. There is no room for excess, no room for waste, no room for error. This constraint, though limiting, is clarifying. It strips exploration down to essentials, and in doing so, it reveals what truly matters. Connection, cooperation, preparation, responsibility. These are not the traits of conquest. They are the traits of stewardship. Perhaps this is what distance really means. Not separation, but responsibility. The responsibility to choose carefully where we go and why. To consider consequences beyond achievement. To value return as much as departure. In this light, the story of how far humans have gone into space becomes less about distance and more about wisdom. We went far enough to see ourselves clearly, far enough to understand our limits, far enough to realize that expansion without understanding is empty. This realization does not close the door. It sets the conditions for what comes next. A future where exploration is not rushed, where distance is approached with care, where presence is meaningful, and where Earth remains central, not as a starting point to escape, but as a home to protect. Distance has given us this gift, not in kilometers, but in perspective. And as we drift gently toward the end of this journey, one final thought remains. The greatest distance humans have traveled may not be outward at all. It may be the distance between how we once imagined space and how we now understand it. Outro. How far we'll go next. As we reach the end of this journey, there is no final destination to arrive at. No dramatic horizon. No triumphant landing. Only a gentle pause. Because the story of how far humans have gone into space does not end with distance. It ends with understanding. We began by asking a simple question. How far into space have humans actually gone? Along the way, we measured kilometers. We traced orbits. We followed trajectories beyond the moon. We watched machines drift into darkness. And slowly, the question changed. It became less about how far and more about what it means. Humans have gone far enough to leave Earth, far enough to look back, far enough to realize how fragile home is. And that realization may be the most important journey of all. When people imagine the future of space exploration, they often picture motion, rockets launching, planets reached, new worlds touched. But the future may unfold differently, more quietly, more patiently. Instead of dramatic leaps, there may be steady steps. Instead of conquest, presence. Instead of urgency, readiness. The moon will likely be our next chapter, not as a race, but as a return, a place to practice living away from Earth without losing connection to it. Mars may follow, not as an escape, but as a question: can humans sustain life far from home for long periods without breaking? These missions will not be defined by how far they go. They will be defined by how well they are prepared. And preparation takes time. There is no shame in this. The universe is not impressed by speed. It has existed for billions of years. It will continue long after us. We do not need to rush. Space does not demand urgency. It demands care. Perhaps the future of human spaceflight will not resemble the past. Perhaps it will involve fewer flags and more foundations, fewer firsts and more continuities, habitats that grow slowly, systems that last, presence that feels earned, not forced. And perhaps this future will not be loud. It will not announce itself. It will arrive quietly, through consistency, through patience, through learning. This aligns with everything space has taught us so far. That silence is powerful. That distance humbles. That fragility matters. We have learned that Earth is not replaceable. That distance does not equal freedom. That exploration is not about leaving something behind, but about understanding what we carry with us. Every mission takes Earth along. In air, in water, in biology, in culture. No matter how far we go, we remain connected. This connection is not a limitation. It is an anchor. It gives meaning to return. It reminds us why exploration matters in the first place. Without home, there is no away. So how far will we go next? The honest answer is, we don't know. And that is okay. Because not knowing does not mean unprepared. It means open. Open to learning. Open to restraint. Open to choosing the right moment rather than the fastest one. Space will still be there. The moon will still orbit. Mars will still glow in the night sky. The stars will remain distant. They are not waiting impatiently. They are simply there. And when humanity is ready, truly ready, we will go. Not because we can, but because it makes sense. Until then, we continue to orbit, to study, to reflect, to look outward and inward. At the same time, this quiet phase, this pause, is not an ending. It is a breath, a moment of stillness between steps. And perhaps that is exactly where humanity belongs right now, close enough to Earth to remember what matters, far enough to see it clearly, So, as this journey comes to rest, there is nothing left to prove, only something left to protect. A small blue world, hanging in darkness, that gave rise to curiosity and patience, and the desire to understand. That world is still home. And no matter how far we go, it always will be. Good night.